So this is the exploration that I had you guys do. We were supposed to watch 2 con videos first to learn about what scale was, just learn about scale in general. And then we were to explore it, figure out what's going on with this whole scale thing. So we're creating a scale drawing. Here, this was a picture of the zoo, right? We had the grasslands exhibit, we had the farm animals exhibit, and the bird exhibit. And it was told to us, let me see if I can't get a different, well, I can't. Let me try something different. Sometimes I have to use the keyboard to exit out of this magical large function. Not this. There, that's what I want. So we were told that each centimeter in the drawing represents 4 meters. So we saw that this was 4 centimeters, so how long was this?
16 meters.
16 meters, right? And that's what we were supposed to discover. So then when we got to this problem, it says, describe the relationship between the lengths of the fences in the drawing and the actual side lengths of the fences. And so like this fence was 4 centimeters in the drawing, right? But it was 16 meters for the actual side length. So it would be 4 centimeters to 16. And why did I write like this? Because I told you to write a ratio with units, right? So a ratio, remember, what is a ratio? Yeah, Ashley? Using close? Using division. And fractions are a way to write division, absolutely. It's a comparison of 2 things using division. So, what were the 2 things we were comparing? The drawing length, the actual length. So this was 4 to 16. Or, you could simplify that and get 1 to 4, right? Oh, thanks so much. Love me some apple juice. So what we see is this value, each centimeter in the drawing represents 4 meters. This, I made a note to you guys, and I said this ratio is called a scale. Now, I'm going to give you the formal definition today in class, but that's what a scale is. So when you move on, it says describe the relationship between the areas in the section. Well, how do we find the areas? Well, for me, I'm going to look at the easy area. Which of those sections is the easiest area to find?
The grassland.
Yeah, the grassland, the square one, right? What's the area on the picture? Well, it could be 4 times 4, right? 4 times 4 centimeters, which is 16 centimeters squared. The area in terms of the actual area would be 16 by 16, which is 256. So the way that simplifies is that simplifies to 1 and 16. So the areas have a relationship of 1 to 16. But that's because we're talking about square units. What's 1 squared? What's 1 squared?
1.
What's 4 squared?
16.
Interesting. Remember the scale? The scale was 1 to 4 from the first page. And then it's saying, are these ratios the same? No. The ratio between the lengths and the ratio between the areas is not the same. So that was what we saw on the answer key. Now you guys did have the answer key to this to talk through, to look through, to make sure, all right, am I on the right track? What the heck what am I even doing? So I gave you guys some examples of different scales that we could have used. So the scale on the image that was the one that was given to you was 1 to 4. 1 centimeter to 4 meters. These are some other examples of scales we could use. 1 centimeter to 8 meters. 1 centimeter to 16 meters. Why would 1 centimeter to 10 meters be a not very fun scale to use?
Because you can't divide them by each other?
Mm-hmm.
Or you can't?
It's not a multiple or a divisor of 4. So the scale that was given to us was 1 to 4. So it's easier to scale things up if they're multiples of each other. So what we're going to do is, so you had that centimeter paper. And these are some of the possible answers that you could have gotten, some of the possible drawings. So notice this is the 1 to 8 scale. The 1 to 8 scale would be 1 centimeter on here represented 8 meters. Well, remember how long the grasslands fence was? How long was it in the real world? It was 16 meters, right? So now my new scale is 1 to 8. So 1 centimeter would equal 8 meters. So how long should it be on the picture? if in real life it's 16 meters, how long should it be on the actual picture? It'd be only 2 centimeters. Why? Yeah?
Because if you're gonna end up doubling like 1 centimeter, which equals 8 meters in real life.
Yep,
So 2 centimeters equals 16 meters
in the real life. That's what a scale is. It's just 1/2 of the proportion that we would set up. So if you were going to use this as your scale, then the proportion you'd set up would be 1 centimeter over 8 meters equals how many centimeters over 16 meters? Why? Why 16? Because we figured out that was the actual length of the grasslands, right? That was the actual length. And that's not going to change. Is the fence in the real world going to change? Only if they expand. You're not told that. What is going to change is how we're representing it. So then the rest of them just kind of follow suit. This was a 1 to 16 scale. So 1 centimeter on here represented 16 meters. So how many centimeters does the grasslands need to be? 1 centimeter, because in real life it was 16 meters. Now, I'm going to rotate this sideways so you guys can see it a little bit differently. This is my, zoom out just a hair. This is my 1 to 2. So my 1 centimeter to 2 meters scale picture. So if the actual length is 16 meters, and each centimeter represents 2 meters, how many centimeters should the grasslands fence be? 8. Because this is 2 centimeters, 2 meters, 2 meters, 2 meters, 2 meters, 2 meters, 2 meters. So 8 centimeters would give me 16 meters. So it would be a lot larger for this one. Because the scale is smaller, isn't it? 1 to 4 would make a smaller picture than 1 to 2. It's like saying, I only want to split you guys into 2 groups. Would your groups be bigger than if I split you into 4 groups? Yeah, if I split you into 2 groups, it's going to create a bigger image. We create bigger groups. If I split you into 4 groups, like the example, well, then it will be smaller. So this is how a scale works. To rotate twice around. You can only rotate clockwise. And so then we get to the back here. We're talking about dimensions of this thing. So we're given the scale, 1 inch equals 8 feet. That's our scale. But we know that each box is a 1/2 inch. So if the scale is 1 foot to 8 feet, if each box is 1/2 inch, what's the real length in the real world of this box? 4 feet. If 1 inch equals 8 feet, right, if 1 inch is 8 feet, each box you're told, each square is a side length of 1/2 inch. So 4 feet, 4 feet. Notice I just labeled them all 4 feet because that made it easier for me to count. So it's saying, what are the dimensions of the bedroom suite? Well, that's the whole thing, the bedroom suite. So the title at the top, bedroom suite. So the dimensions of the whole thing would be 1.5 inches by 2.5 inches. Well, we know that each 1/2 inch is 4 feet, so it'd be 12 feet by 20 feet. Dimensions of the bathroom up at the top, 4, 4, 4, and 2, so it'd be 8 by 2. Or excuse me, 8 by 6. And then the length of the longest wall in the bedroom, I highlighted that in yellow. That's the longest wall. So all I did was trace it. So what we did with our scale was we just applied the scale to the image. If the scale was 1 inch equals 8 feet, then 1/2 inch would be 4 feet over and over again. Then we got to talking a little bit about areas versus perimeter. We're going to dive too deep into that right now. Number 6 was a very difficult question, so we'll go past that in a second. But here, I gave you a hint of how to set it up. Remember, this was an exploration. We were supposed to struggle with it. You weren't supposed to know everything, okay? It was an exploration. So, I told you set it up 2 over 5 equals something over something, right? That's what the hint I gave you. Well, 2 over 5 is the scale. That means that the model comes first. Scale, the model comes first. So the model is 2, and the actual is 5. So if the depth is 10 kilometers, then the depth would actually be 25 kilometers. How do we do that? Well, because 2/5 equals 10 over what? And you just solve that proportion. 2/5 equals 5 over what? You solve that proportion. 2/5 equals something over 24, and 2/5 equals something over 32.5. So all scale is just a specific application of proportions. It's telling you what your ratio is on an image, a map,